Okay, today we're going to talk about DNA replication. You do not need to write anything yet, but when cells go through mitosis or meiosis, each cell needs to have a copy of the same DNA. Okay, so DNA needs to copy itself before a cell can go through mitosis or meiosis. So the big question is, how does DNA copy itself? That's a great heading for today. Actually, just wait. Let's do this. Here's a great heading. DNA replication. There's not a ton of notes for today, but the stuff that we do write down is important. So DNA replication. When you replicate something, you copy it. So we need to copy DNA. And here are the steps. Step 1. DNA splits down the middle, or unzips. DNA splits down the middle, or it unzips. So, if I was going to recreate that here, here's a strand of DNA. Okay, now remember, we have the phosphate on the side. Phosphate, I can't spell today. These are nitrogen bases. And then where they meet right here would be the deoxyribose sugar. So those are the parts of DNA. Okay, now when it's going to begin copying itself, it's going to unzip. So if you think of it as a zipper, okay, it's going to look like this. Okay, now remember the nitrogen bases are paired up A, T, G, and C. A always goes with T, G always goes with C. So if I'm just making these up here, but G, C, let's say T, A, T, C, G, T, A. All right, so you see it's kind of unzipping, just like a zipper. It pulls apart here, okay? And it's going to continue pulling apart as we go. So back to this. So it's unzipping. Step 2. Go ahead and write this, please. Extra base pairs, extra nitrogen bases, ATs, Gs, and Cs, are floating around in the cytoplasm, and they're going to combine with each side of the DNA. Take a moment, write that. If I'm going too fast, you can always pause. Now back here, in the cell, we have some extra A's and extra T's and extra C's and extra G's floating around here. And what's going to happen, it's kind of like spare parts. It's kind of like going to a junkyard. You need a part for your car, okay? There's a bunch of old cars there with some spare parts, okay? And your cell is basically going to take these spare parts and they're going to fill them in. So it might take this extra A right here and put it over here. Oh, and then we have a C here, so what matches with C? Oh, G, here's one. Okay, oh, we need a T here. And it's going to fill those in. Same thing with this side here. Oh, we need an extra A. We need an extra C. We need an extra T. And we end up with It just continues on and on and on. We're going to end up with 2 strands. And you notice that they're exactly the same when we fill these in. There's an AT, CG, CG, TA, TA. So it unzips, and then it fills it in with spare parts. Hopefully that makes sense. We're back here, going on. Sugar and phosphate molecules form the other sides to make 2 DNA molecules. So basically there's extra sugar and extra phosphate. That'd be the sides of the ladder and the bolts to put that bad boy together. And that's kind of a cool little animation there. You see the zipper, it unzips, it fills in the extra parts, the spare parts, continues to unzip, and pretty soon you end up with 2 new pieces. So it's pretty simple. Now, when does this happen? When does DNA replication happen? Go ahead and write this down. When does DNA copy itself, basically? And the answer is during interphase. So during interphase, when a cell is spending most of its life hanging out in interphase, doing cell things, it's going to copy its DNA. It's going to do this unzipping and finding the spare parts and putting it back together and having 2 strands of DNA. One last thing, mutations. And I'd maybe write down, maybe underline mutations. This is a kind of a vocab word that I guarantee will be on your test. Mutations are caused by mistakes that can be made during DNA replication. So, sometimes mistakes happen. When DNA is copying itself, sometimes they happen. Now, understand that each one of your cells is doing this, and you have billions and billions of cells. Something is bound to go wrong once in a while. Okay, if I put a paper in the copy machine here at school, and it asks me for how many copies do I want, and I say 1 billion, something's going to happen. I'm not going to have 1 billion perfect copies. Something's going to happen. I'm going to have a paper jam. I'm going to have something go wrong. Okay, well, the same thing with your cells. 99.9% of your cell copying is going to be perfect. But once in a while, there's going to be ones that just get messed up, and those are called mutations. Some of those are small mutations, like maybe you have a mole or a birthmark. That would be a mutation. We all have something like that. Some diseases are caused by mutations. I had a student a few years ago with 2 thumbs on the same hand. That's a mutation. As it turned out, that mutation ran in his family. His dad and his grandpa and one of his uncles had 2 thumbs on the same hand as well. So something went wrong down the line there, and it caused that. Cancer is a mutation. Something happens in the copying of the cell, and it creates a cancerous cell that then grows and grows and grows and becomes something bad. Most of the time, those mutations are caused from things like sun exposure, like skin cancer, or maybe if you smoke, something like that. My grandpa smoked a pipe for like 50 years. And he put the pipe in the same spot on his lip for 50 years. Well, guess where he got cancer? On his lip, where he always had his pipe. He had a cancerous growth there that they had to cut off because of years of being exposed to tobacco on his lip caused some mutations. So a mutation is a big change or a big mistake when DNA copies itself.